Welcome to ACE Engineering Academy Online. I am Dr. AVS Prasad, Engineering Maths faculty at ACE Academy. In this session, I am going to discuss preparation strategy of linear algebra, important concepts, problems on linear algebra for GATE 23. So this is my email ID, avsprasad at ACE Engineering Academy. You can send the queries to this mail ID. So let's see the syllabus first, right? So what are the subtopics in this linear algebra? So the first one is basics of matrices, and the second one is rank of matrix. Third one is system of linear equations, and eigenvalues and eigenvectors. Similarly, Cayley-Hamilton theorem, and linearly independent dependent vectors means how do we verify given a set of vectors are linearly independent or dependent. And basis and dimension, this is right. This concept is only for ECE branch, and this LU decomposition last one is for CSE branch. So we'll be discussing these concepts. Okay, right. Reference recommended books for this linear algebra are the following. Let us see, the first one is ACE Engineering Academy material. This is the first priority. Our book contains good theory and good number of problems on linear algebra, right? And next one is Advanced Engineering Mathematics by Erwin Kressings, not only for linear algebra, for other concepts also. This is very good book for GATE and engineering service exams. And third one is Linear Algebra by Gilbert Stang. This is also very good book for linear algebra. Right, these are enough, right? And what type of problems are coming in the GATE exam, right? GATE paper on linear algebra. So I have gone through the previous GATE papers and I observed the following are the frequently identify the following are the frequently occurred models on linear algebra. So problems related to basic concepts, problems related to rank of matrix, these were occurred frequently. Problems related to system of linear equations, problems related to eigenvalues and eigenvectors. There are various types. A matrix is given finding eigenvalues, and matrix and eigenvalue is given finding eigenvector. Different models are there, will be discussed, right? And problems related to Cayley-Hamilton theorem, applications of Cayley-Hamilton theorem, and problems related to different types of matrices. There are various types of matrices like symmetric, skew symmetric, Hermitian, orthogonal, unitary, and idempotent, nilpotent, etc. Problems related to those matrices. And problems related to LU decomposition, as I told you earlier, this is only for CSE branch. And problems related to linearly independent dependent events. Okay, so these are the frequently occurred models on linear algebra in the GATE exam, right? Next one is what type of what type of questions are coming, right? So basically we know that there are 1 mark and 2 mark type questions in the GATE paper. So 1 mark question and 2 mark questions are coming, and again the questions are 3 different types of questions are there: numeric answer type, multiple choice questions, and multiple select questions. Means more than one option will be is going to be correct. And next one is concept based questions also coming, and simplification type also. This topic has weightage up to 3 marks. This is one of the easiest topic in the GATE syllabus, engineering mathematics syllabus. Okay, right. So how do we prepare? What is the preparation strategy? Watch our online videos or recorded videos, or if you are from offline mode, see the classroom notes and prepare your own short notes. Right, it helps you to revise the concepts. Right, so don't depend on other short notes. You have to prepare your own short notes. And next one is mark important formula and properties, like there are various properties. Those are very useful to solve the problems. And practice previous year exam questions. And attempt our ACE Engineering Academy test series. This is the best preparation strategy to get the good marks on linear algebra. Okay, right. So we begin, we discuss the theory first and problems related to this linear algebra. Let us begin with the determinant of a matrix. So what is the determinant of a matrix, and how do we calculate the determinant for 3 by 3, 4 by 4, 5 by 5 higher order matrices? Okay, right. See, suppose A equal to, it is a 3 by 3 matrix here, a 3 by 3 matrix is considered. Look at here. If A equal to A11, A12, etc., it's a 3 by 3 matrix. We know that the determinant is denoted by det A or delta or det A, this is the notation, right? So the determinant is nothing but this is the determinant of the matrix. Here determinant is expanded along what? First row. Look at A11 into this one. So A11 into, by deleting this row and the corresponding row and column remaining determinant. So this is called minor. So this element is called minor, we know that. This is called minor. And this is multiplied with minus 1 whole power I plus j. That is minus 1 whole power 1 plus 1. So it is called cofactor. So A11 in its cofactor plus A12 its cofactor plus A13 into its cofactor. So can we say that determinant of matrix is nothing but sum of the product of any row or column element and corresponding cofactors. Okay. So here determinant is expanded along only first row. You can expand along second row or third row, any row, any column. Okay, this is the determinant of a matrix, right? So finally, we can say that what is the determinant definition? If A equal to Aj square matrix of order n, then the sum of the product of elements of any row or column with the cofactors of the corresponding elements of column or row is called the determinant. Okay, as I told you, determinant is nothing but simply the sum of the product of any row or column element and corresponding cofactors, right? So this is the definition of a determinant of a matrix. See, there are various properties. These are very useful to solve the problems related to determinants. Okay, so these properties are very important to us. Let us see the properties. The first property is if A and B are two square matrices of same order, then det of AB equal to det A into det B. Okay, right. And next one is, the second one is determinant of A power m equal det A whole power m. So that is determinant of A square equal det A whole square, determinant of A cube equal det A whole cube, etc. Similarly, determinant of if determinant of A is non-zero, right, then A inverse, determinant of A inverse equal to 1 by det A only. Means what I am saying is, for example, if det of A equal to 3, that implies det of A inverse equal to 1 by det A, so it is going to be 1 by 3 only. Similarly, what about this property? Determinant of A power m means what? That is determinant of, for example, A square is required. So determinant of A square equal to 3 square only, equal to 9 only. So this is the property. So these properties are very useful to us. We use frequently these properties, right? Similarly, look at next one is, right. Next one is all zero property. What is all zero property? If every element of a row or column, right, is 0, if every element of a row or column of determinant of A is 0, then det of A equal to 0. Means, for example, right, simply, right, 0, 0, 0, 1, 2, 3, 2, 1, minus 1. Look at here, first row is completely a 0 row or not? So without any calculation, we can say that directly determinant of this matrix is 0 only. Similarly, next one is reflection property. What is the reflection property? If A is a square matrix of order n, then det of A equal to A transpose only. Means what? Determinant of A and A transpose are same only, right? Similarly, proportionality or repetition property. What is the proportionality repetition property? If the corresponding elements of any two rows or columns of a determinant are proportional or in the same ratio, then the value of the determinant is 0 only. Means, for example, determinant of 1, minus 2, 1, 3, minus 6, 3, 1, 5, 7. Okay. Look at once here. First row and second row are proportional or not? Second row is what? 3 minus 6, 3. First row is 1 minus 2, 1. So second row is nothing but 3 times first row or not? So without any calculation, the determinant is 0 only. So this is what property? Proportionality or repetition property. If the corresponding elements of any two rows of a determinant are proportional or in the same ratio, then determinant is 0 only, right? Similarly, switching property. What is the switching property? If two rows, two columns are interchanged, then the determinant is to be multiplied with minus 1. That is called switching property. Look at in this example, 1 to determinant of 1, 2, 3, 4, 5, 6, 7, 8, 0 is suppose 27. So 7, 8, 0, 4, 5, 6, 1, 2, 3 is determinant is what here? So look at here, first row and third row are interchanged or not? So determinant is minus 27. So what is the switching property? If two rows, two columns are interchanged, then the determinant is to be multiplied with minus 1. Next, scalar multiple property. What is scalar multiple property? If every element of a row is multiple of k, then determinant is to be multiplied with k. That is, k is to be taken as common. Look at here, 1, 2, 3, 4k, 5k, 6k, 7, 8, 0. Look at every element of second row is multiple of k or not, scalar multiple k or not. So we can take out k as common. Okay, right. So if all elements are multiple in general, if all elements are multiples of k, then we can take out k power n as common. Right, means what? If it is a 3 by 3 matrix, from the first row 1k, second row another k, third row another k, so k cube. So what is n here in general? N is nothing but here n equal to order of matrix. What is n here? N is order of the matrix. Okay, this is the 8th one. Look at sum property. What is the sum property? If the each element of a row or column of determinant is expressed as a sum of two or more terms, then the determinant can be expressed as the sum of two or more determinants. Okay? For example, look at det of a plus lambda 1, b plus lambda 2, c plus lambda 3. So first row elements are sum of two elements or not? So this determinant can be expressed as sum of two determinants. This is also very important property. Similarly, 9th one is look at triangular property. What is the triangular property? This property is used frequently, right, while solving the problems. Look at what is the property? The determinant of upper triangular, lower triangular, diagonal matrix here. Diagonal matrix is equal to just product of the diagonal elements only. For example, look at suppose determinant of 1, 2, 3, 0, 4, 5, 0, 0, minus 1 is required. So it is a upper triangular matrix or not? So diagonal elements are what? 1, 4, minus 1. So the determinant is 1 into 4 into minus 1 only. So equal to minus 4 only. So this is called a triangular property. So determinant of upper triangular matrix or lower triangular matrix or diagonal matrix is just product of the diagonal elements only. Okay. Property of invariance, right? If each element of a row of a determinant is multiplied by the same constant k and added to the corresponding element of another row, then the value of the determinant remains same only. For example, look at here 1, 2, 3, 4, 5, 6, 7, 8, 0. These are the elements, right? These are the this is the first row, second row, third row. Look at every element of second row is multiplied with k and added to first row or not? So the determinant remains same only. So this is called property of inverse, right? So under the elementary row or column operations, the value of the determinant is unchanged. So what type of operations? These type of operations are to be performed, right? So Ri implies Ri plus k times Rj, Ci implies Ci plus k into Cj, then the determinant remains same only. Okay? So these are the important properties right, which are very useful to solve the determinants problems. Look at. So why do we get wrong answers or different values for determinant in general? Because of this, right. So you have to remember these operations, right. So these type of operations, by performing these type of operations, we get the correct answer only. But look at once here, the problem is look at. So correct and incorrect operations. Right. So what I am saying is Ri changes, Ri plus k times Rj. Right. Then the determinant remains same only, no change in the determinant. Similarly, Ci changes, Ci plus k into Cj. That is property of invariance. Okay. So to these type of determinant is not affected by these type of operations. But whenever look at, for example, Ri changes, k times Ri plus Rj, you get a different answer. So such operations are not allowed. Similarly, Ci changes, k times Ci plus Cj. So we get a different answer. Similarly, these type of operations are not allowed. Ci changes, Ci into Cj. Ri changes, Ri into Rj, right? So these type of operations are not allowed. these type of operations are only allowed, right, while simplifying the determinant problems, particularly higher order problems, 4 by 4, 5 by 5, 6 by 6, etc. Right? So let us see once here Ri changes, Ri plus k times Rj. Means what here? Every element of another row, Rj, is multiplied with k and added to Ri. But here, what does it mean? Look at here. We are going to apply the operation on Ri, and every element of Ri is multiplied with a scalar k. Understood or not, right? So this leads to wrong answer. So these are not correct. These type of operations are not allowed. So these type of operations are only allowed. And you can apply the interchange operation also. But whenever interchange operation is performed, the determinant value is to be multiplied with -1. Right. So these are the important properties. So how do we find the determinant of higher order matrices? 3 by 3, 4 by 4, 5 by 5, 6 by 6. 3 by 3 not a problem, but 4 by 4, 5 by 5, 6 by 6, etc. So these are the some hints or tips to find the determinant of higher order matrices. Try to perform the operation in a manner so we can take something common and create all one. Okay? So try to perform the operation in a manner so we can take something common and create all one. Okay, by adding or something, right? Next, once we get all ones in a row or column, then convert them into 0 as many as possible. So try to convert them as many as zeros, okay, and then expand along that row or column. This is the procedure. So finally we can say that try to expand the determinant along a row or column having maximum number of zeros. Okay, this is the procedure to get the determinant of a higher order matrices. Okay. So shall we do questions related to these determinant and basic concepts? Right, look at. And before, right, look at, let us see another one, that is adjoint matrix also. The properties related to adjoint matrix also required for us. Look at. If adjoint matrix means what? Adjoint matrix is nothing but transpose of the cofactor matrix. What is the cofactor matrix? Minus I whole, minus 1 whole power I plus j into cofactor. Each element of the cofactor we calculate and we take the transpose of that matrix. So if A is a square matrix of order n, then A into adjoint A equal det A into n. This is the first property. Next, second one is if A is a square matrix of order n, then adjoint of A transpose equal to adjoint A whole transpose. If A and B are non-singular matrices, then adjoint of AB equal to adjoint of B into adjoint of A only. Right. And look at next one is adjoint of K equal to, what is K here? K is a scalar. K power n minus 1 into adjoint of A. If det A is equal to 0, then adjoint of A is also 0. Next, if A is a square matrix of order n, this is very important property, sixth one is, right? Det of adjoint of A equal to det A whole power n minus 1. Similarly, determinant of adjoint of A equal to det A whole power n minus 1 whole square. In general, similarly, adjoint of, in general, adjoint of so on, so on, so on, adjoint of A. So here k times, suppose k times. So this is equivalent to det A whole power n minus 1 whole power k only. What is n here? What is n here? Here n is order of the matrix. Order of the matrix. That is size of the matrix. Okay. So this is very important property. We have to remember this one. If A is a square matrix of order n, then the adjoint of det of adjoint of A equal det A whole power n minus 1, etc. Right. Let's see the next one. So what are the properties of inverse? Right. The necessary and sufficient condition for a square matrix A to possess the inverse is that det of A is non-zero. Yes, we know that for determinant non-singular matrices only A inverse exists. If the inverse of square matrix A exists, then it is unique only. So for a matrix only one inverse exists. If A, B, C are non-singular matrices, then AB whole inverse, this is called reversal law. AB whole inverse equal to B inverse A inverse. Similarly, ABC whole inverse equal to C inverse B inverse A inverse. And if A is non-singular matrix of order n, then A transpose whole inverse is same as A inverse whole transpose only. Right. So let us see the problems related to these basic concepts. Okay. Right. Look at the first problem is the determinant of a matrix is what? What is the matrix here? 0, 1, 1, 3, 1, 2, 3 minus 2, 1, 3 minus 1, 1, 0, 0, 1, 2. So it's a 4 by 4 matrix. Look at how do we find the determinant of this 4 by 4 matrix? right. So 0, 1, 1, 0, 1, 2, 3, 0, 1, 3, minus 1, 1, 3, minus 2, 1, 2, right. So what I told you, expand the determinant along a row or column having maximum number of zeros. Look at this first column has maximum number of zeros, 2 zeros, and even last row also having is also having 2 zeros. So I'm going to get I'm going to make this element as 0 to get one more 0, right? So what operation? R3 changes by performing R3 changes, R3 minus R2. So we can apply this type of operation, right? So R3 minus R2 means what? It is going to be, look at once here. So it is going to be 0, 1, 1, 3 remains same only. 1, 2, 3 minus 2 remains same only. 1 minus 1, 0, 3 minus 2, 1, minus 1 minus 3 minus 4. Next 1 minus of minus 2 is 3 only. Next one is 0, 0, 1, 2 only. Okay. Look at our first column has maximum number of zeros or not. So 1, 2, 3 zeros are there, right? So I'm going to expand along the first column, right? So what are the signs here? Plus, minus, plus, minus. These are the signs. So the determinant is going to be, look at, it is going to be expanding along the first column. It is going to be plus 0 into something 0, minus 1 into. What is minus 1? Minus 1 into remaining is what? By deleting this row and this column, remaining is what? 1, 1, 3, 1 minus 4, 3, 0, 1, 2. Okay, right. Next one is plus 0 into something anyway 0, minus 0 into something 0 only. Right. Next one is, this is to be simplified. So the right, look at this is equal to minus 1 into. Again, look at determinant of this is just 3 by 3 matrix only. Look at. So 1 into deleting this row, this column, minus 8, minus 3, minus 11. Okay. Next one is minus 1 and expanding along first column. So minus 1, deleting this row, this column is what? 2 minus 3, minus 1. Next minus 0 and plus, minus here, again plus, minus, plus. So here again plus 0 and something anyway 0 only. Look at this is going to be, right, minus 11 plus 1, that is minus 10. Minus 10 and minus 1. So answer is what finally? So this is equal to plus 10 only. So this is the procedure, right? So similarly, we can find the determinant of 4 by 4. This is 4 by 4, right? 5 by 5, 6 by 6, 7 by 7 also, right? By performing the elementary operations. So finally, what is the answer? Answer is 10 only. Am I right? Is it correct or not? You can post your answer in the chat box. Yes, good evening, Nirisha, Rahul. Yes, am I right? Answer is 10 or not? So final answer is 10 only. Right. Let us see the next question. If A equal to 6722, then the determinant of A power 2004 minus 2 times A raised 2003 is what? What is the value of, right? What is the value of the determinant of this one? Look at. So here, what is the required value? Determinant of, look at determinant of A power 2004 minus 2 into A power 2003 is required. Right. People used to solve this problem like this. This is equal to det of something, right? Det of A power 2004 minus 2 times this one. But this is absolutely wrong, because we don't have any formula like determinant of A plus or minus B is equivalent to, right, det A plus or minus B. There is no det A B. This is not equal. This is not equal. So we should not apply such formula, right? So what is the alternative? So the alternative is, look at, right, how do we solve this one, right? So therefore, determinant of, right, so this is going to be, look at, can we take this one as, from this one as, a power 2003 is, can we take a power 2003 as common or not? Remaining is what? A minus 2 times I only. So is there any formula related to this one? Yes, we have a formula. What is the formula? Determinant of A B equal to det A into det B only. So therefore this is going to be det A whole power 2003 into determinant of A minus 2I only. Yes, am I right? Correct or not? So determinant of A power 2003 is what? First of all, det A is what here? Look at what is the matrix here. The matrix is 6, 7, 2, 2 is the matrix. So therefore, det of A equal to 6 2s are 12, 12 minus 14. So it is going to be minus 2 only. Next, A minus 2I value is required for us. A minus 2I. What is A minus 2I? I means what? You know that I means what? Identity matrix only. So A minus 2I means what? It is going to be 6 minus 2, 4, 7 remains same only, 2 same only, 0 only, right? So this is the A minus 2I matrix, and det of A minus 2I is what here? Det of A minus 2I equal to 4 minus 4, 0 and minus 14 only. So this is going to be, look at, this is going to be finally A power, det of A power 2003 means what? Det A whole power 2003 by our properties. Because we have a property, we know that, what is the property? Det A whole power m, det of A power m equal det A whole power m. And this one is what? Minus 14 only, right? And what is det A? What is det A here? Det A is here minus 2. So this is going to be, look at, so this is going to be minus 2 whole power 2003, and minus 14 can be written as minus 2 into 7 only. So this is going to be therefore minus 2 whole power 2004 only, okay, into 7. So minus 2 whole power 2004 means what? 2004 is even number. So minus whole raised to even number means what? Positive only. So it is going to be 2 raised to 2004 into 7 only. This is the value. Okay. So which option? See once the options, right? So the option is, option B is the correct answer. Yes, Nirisha, option B is the correct one. Okay, right. Let us see the next question. Let m power 4 equal to I, where I denotes the identity matrix, and m not equal to I, m square not equal to I, m cube not equal to I, then for any natural number k, m inverse is what? Okay, what is the inverse of the matrix? Right. See, once here 4 options are given, right? 4 options are given. Option A something, right? M raised to 4k plus 1. Option B m raised to 4k plus 2. Option C m raised to 4k plus 3. Option M raised to 4k. Right. How do we solve this one? Look at. See, m into, we know that m into m inverse equal to m inverse into m equal to identity matrix I or not? The properties of inverse of a matrix, right? Look at here, one of the option is m inverse only. So multiply with m, means verification options, right? We are going to verify the options. So for example, option A. So option A verification, m into m power 4k plus 1. Okay, is equivalent to I or not? This is 1 minute, right? 4k plus 1, right? So if it is equivalent to I, then option A is going to be, right, would be correct answer, right? Look at m into m power 4k plus 1 means what? M power 4k plus 2 only. So that is what? M power 4 whole raised to k into m square only. M power 4 is what? Identity matrix I. So this is going to be I power k into m square only. I power k is what? I only. Right? I means identity matrix. So I into m square means m square only. But given that m square is not equal to I, so option A is not a correct answer. So similarly verify option B, option C, right? Let us see the option C, m into m power 4k plus 3. Similarly you can verify the remaining 2 options also, right? M into m power 4k plus 3 means what? M into m power 4k plus 4 only, in fact. Look at 1 minute. Right, 4k plus 4. So this is going to be, look at, this is going to be m power 4k, 4 whole raised to k into m power 4 only. So m power 4 is already I, given that I. So I raised to k means I only into I. So this is I only. So m into m power 4k plus 3 equal to I means what? M power 4k plus 3 is the inverse. So option C is going to be correct answer. Similarly, you can verify option B and option D also. Is it right? Understood or not, right? So very good example on inverse of matrices. Right. Yeah, which option? Nirisha. Yes, C is the correct answer, right? So m power 4k plus 3 into m equal to m inverse. M into m inverse equal to I. Right. So I am moving to next question. Look at the next one. Perform the following operations on the matrix A equal to 2, 6, 3, minus 1, minus 3, minus 2, 5, 15, 10. Okay. What are the operations? Add the first row to the second row. Add the first row to the second row. Next, second one is what? Multiply every element of third column by 4 and subtract from the first column. Then the determinant of the resultant matrix is what? Look at. So what I am saying is you are required to find the determinant of this matrix by performing these operations. What operations? What is the first operation? The first one is, look at, add the first row to the second row. That is R2 changes R2 plus R1. Add the first row to the second row. Next, what is the second operation? Multiply every element of third column by 4 and subtract from the first column. That is C1 changes C1 minus 4 times third column, that is C3. So by applying these operations we get a new matrix. So what is the determinant of that resultant matrix? But we know that determinant of matrix is not affected by elementary operations or not. Yes, property of invariance. Okay. So therefore determinant is not affected by elementary operation means what? The determinant of the resultant matrix is going to be same as this matrix or not? We know that, therefore without any computation, look at, right, no need to perform these operations. We know that determinant of resultant matrix is same as, right, is same as determinant of given matrix, because determinant is not affected by the elementary operations. So determinant of given matrix means what? What is the determinant? What is the given matrix? The C ones here, 2, 6, 3, right? So 2, 6, 3, minus 1, minus 3, minus 2, 5, 15, 10. So without any calculation, the answer is 0 only. Why answer is 0 here? C ones here, second row and third column are proportional or not? By what property? Property of proportionality. Since the reason is what? R3 equal to minus 5 times R2 only. So they are proportional. So by the property of proportionality, the determinant 0 only. Right? No need to perform the operations. So option is, answer is 0 only. Yes, Nirisha is saying that 0. Yes, 0 is the correct answer. Am I right? Understood or not? Very good example on properties of determinant, right? Without any calculation, directly using the properties, we can answer these type of problems. Right. So I am moving to next question. Right. So next concept is rank of matrix. What is the rank definition? What are the methods to find the rank of the matrix? And what are the properties of rank of the matrix? Okay, we will be discussing these concepts. So rank definition is a non-negative integer R is said to be the rank of the matrix A if there exists at least one non-zero minor of order R, and second one is all minors of order R plus 1. If they exist are zeros, then we write the rank of A equal to R. This is the rank of the matrix definition. What is a minor? Minor means what? Determinant of the square submatrix. By deleting row and column, few rows and columns, we get a square submatrices. Then determinant of that matrix is called minor. This is one definition, right? Let us see the second definition. So that is rank of the matrix A equal to the order of the largest non-vanishing minor of A. That is non-vanishing means what? Non-zero minor of A. And similarly, rank of A equal to the number of linearly independent rows of A or linearly independent columns of A. This is another definition. And the necessary and sufficient condition to verify the given set of vectors are linearly independent or dependent, right? So how do we verify the given set of vectors are independent or dependent? Very simple. write them as a rows of a matrix and reduce into row echelon form. If all rows are non-zero rows, the vectors are said to be linearly independent. Otherwise, the vectors are said to be linearly dependent. That is what the necessary and sufficient condition that the vectors x1 equal to, this is one vector, similarly second vector, n vectors are given. So linearly independent is that rank of A equal to number of, rank of A equal to n, or no row is zero row in echelon form. Linearly dependent means what? Otherwise means what? Rank of A is not equal to n, or at least one of the row is a zero row in the row echelon form, right? We look into what is row echelon form, right? So these are the, basically what is the rank definition? One definition is the order of the largest non-zero minor, or we can say that number of linearly independent rows or linearly independent columns, right? Another one is, this is the best method to find the rank of the matrix, that is row echelon form method. By using this method, we can find the rank of any matrix, right? Whether square matrix or non-square matrix, this is the best method. In this method, we apply only row operations, right? So what I told you in the while finding the determinants, we have to apply the operation like Ri changes Ri plus k into Rj only. Am I right? Correct or not? So whenever interchange operation is performed, the determinant value is to be multiplied with -1. But here not a problem. You can apply any operation, any type of operation. You can apply even Ri changes k times Ri plus Rj also, not an issue. Similarly, you can interchange two rows also, but only row operations are to be performed here. Okay, so please remember that to find the rank of the matrix in the row echelon form, we reduce the given matrix into row echelon form by using the row operations only. What type of row? Any row operation you can perform. So what is row echelon form basically? Even you can interchange operation also, you can apply interchange operation also, but no need to multiply with any -1. In the only determinants, we multiply the final value with -1. So what is the rank of the matrix? A matrix A of order m by n is said to be in row echelon form if the following conditions are satisfied. There are three conditions. Zero rows, if any occur. Zero row means what? All elements are zero, that row is called zero row. Otherwise, we call it as non-zero row. So zero rows, if any occur, then they must be below the non-zero rows. This is the first condition. Second condition is what? The number of zeros before first non-zero element, before the first non-zero element in each row is less than the number of such zeros in the next row. This is the second condition. What is the third condition? Zero rows may have equal number of zeros. So these three conditions are to be satisfied. Finally, right? Finally, we say that rank of A equal to number of non-zero rows in echelon form. Non-zero rows in echelon form. What echelon form here? Row echelon form only. Right. So this is the definition. So we have to reduce the given matrix into row echelon form. And what is the row echelon form? These three conditions are to be satisfied. Right. So let us see. This is very important because next concepts depends on this rank of the matrix. Means solving system of linear equations, eigenvectors, right? To find the geometric multiplicity, we use this rank concept. Even to find the solution of system of linear equation, we use this concept, right? So this is very important. Let us see these following forms are in the row echelon form or not. See once the first one, 1 1 minus 1 0 minus 3 4 0 0 3, right? Is it in the echelon form or not? Yes, exactly, it is in the echelon form. Look at this, the first non-zero element. Before this one we have 1 0. Next row contains more than 1 0, right? Before the first non-zero number. So in the echelon form only, rank of A equal to 3 only here. Next, what about the second example? Let us see the second example. Right. Second example is 1 0 minus 1 0 0 4 0 0. So in this row, first non-zero element is 4. Before that we have 2 zeros. In the next row, more than 2 zeros should be there before the first non-zero number. Yes, we have 3 zeros. So what is the rank of this matrix? Rank of A equal to 2 only here. What about this one? Let us see the third example. So what is the rank of this matrix? We can post your answer in this in the chat box. Tell me what is the rank of this third example? Yes, Nirisha, Venkatesh. Bhavani Shankar. What is the rank of this third example? 0, 1 minus 1. Yes, rank of this matrix is what? 1 only, right? Look at, this is the first non-zero element. Before this one we have 1 0. More than 1 0 should be in this next row. Yes, 3 zeros. Next row also 3 zeros. That is, we have one point here. Clearly I told you that 0 rows may have equal number of zeros, right? So this also in the echelon form only. So rank of A equal to 1 only here. Similarly, look at here. All right, this is the first non-zero element. Before this one we have 1 0. This is the first non-zero element. Before this we have 2 zeros, and this is the first non-zero element. We have 3 zeros. Zeros should increase. What zeros? Zeros before the first non-zero number in a row, right? So finally, this is the echelon form or not? So rank of A equal to 4 only, right? What about this one? Look at here. This is the first non-zero element. Here also first non-zero element, right? Before this one we have 1 0. Next, more than 1 0 is required. But here 4 zeros are there, not a problem. So already in the echelon form, so rank of A equal to 2 only. Next, what about this one? Look at here, this example, 3 0 minus 2 0, this is the first non-zero element. Before this one we have 3 zeros. Next row should contain more than 3 zeros. Yes, we have 4 zeros. Already in the rank of echelon form only, rank of A equal to 2 only, right? Similarly, look at here, 4 0 minus 4 0, 0 0 0 0 4 2 0 0 0 2. Is it in the echelon form? Is it in the echelon form? Nirisha, Venkatesh, Bhavani Shankar, Rahul. Is it in the echelon form? This example. This is not in the echelon form, we have to interchange, right? So we can write this one as, look at, 4 0 minus 4 0, right? 0 0 4 2, by performing the interchange operation, 0 0 2 0 0 0 0, now in the echelon form. So what is the rank of this matrix? There are 3 non-zero rows, so rank of A equal to 3 only. Similarly, look at here, 4 0 2 0 0 0 minus 1 0, last example. So rank of this matrix is 2 only. So these are these few examples related to rank of the matrix. Okay. So I hope you got an idea, understood the concept of rank of matrix. So by performing the various operations, we reduce the given matrix into row echelon, particularly row operations only. Right. So let us see the properties of rank of matrix. So what is the finally what is the observation? Elementary row operations, elementary operations do not change the order of the order or rank of a matrix. To find the rank of the matrix, we have to reduce the matrix A into its row echelon form by using only elementary row transformation. So finally, the rank of A equal number of non-zero rows in the echelon form only, right? So these are the frequently used properties of rank of matrix. Rank of matrix is 0 only for zero matrix. A is null matrix. Null matrix means what? Zero matrix. So can we say that rank of a non-zero matrix is always non-zero or not? Right. So that's why look at, if A is O, not O, O means what? Not a null matrix, then rank of A is always greater than or equal to 1. Next, rank of M by N matrix is less than or equal to minimum of M comma N. This is very important property. Third one is, if det of A is non-zero, then rank of A is exactly N. If det of A is 0, rank of A is less than N. Okay? Right. Similarly, rank of identity matrix is always N only. Rank of A is same as rank of A transpose. And rank of AB less than or equal to minimum of rank A comma rank of A comma rank of B. And rank of A plus B is less than or equal to rank A plus rank B only. And rank of A minus B is greater than or equal to rank of A minus rank of B only. This is also very important property, 11th one, rank of A into A transpose equal to rank of A transpose into A equal to rank of A only. And 12th one is the rank of a diagonal matrix is equal to the number of non-zero diagonal elements only. Very clear. For example, look at 1, 2, 3, 0, 4, 0, 0, this is also 0, this is also 0, look at, and 0, 0. Look at, this is a diagonal matrix or not? Okay, so these diagonal elements are what? 1, 4, 0 are the diagonal elements. So 1 and 4 are the only non-zero elements, right? So very clear, rank of this matrix is 2 only, right? So that's what the property, the rank of diagonal matrix is equal to the number of non-zero diagonal elements only. And this 13th one is very important property. Look at rank of n by n matrix equal to n square matrix, then rank of adjoint is also n. If rank of n by n matrix is equivalent to n minus 1, rank of adjoint A equal to 1. If rank of n by n matrix is less than or equal to n minus 1, then rank of adjoint A is going to be 0. Means what? But what I told you, rank of A never becomes 0. But here rank of adjoint A equal to 0 means what? In this case, adjoint A is a null matrix, no doubt. You can take an example and verify, right? In this case, adjoint A is equivalent to null matrix, that is O. Okay? So these are the frequently used properties. Frequently used properties or important properties are related to rank of the matrix. Right. Let us see the first problem on rank of matrix. The rank of the matrix is what? Okay. So here this is the matrix 4 0 4 minus 4 something, right? So how do we find the rank of this matrix? By reducing into row echelon form. Row echelon form is the best method, right? Look at. So look at here I am going to make this first element as 0. That is R3 changes, R3 plus R1. So we get it is going to be 4 0 minus 4 0, and next one is 0 2 0 1 0 0 0 and 0. Next one is what? 0 1 0 2 only. Right, look at. So here we have a completely 0 row. So the 0 row should lie below non-zero rows. So it can be reduced, right? We can apply the operation like R3 and R4 are interchanged, right? R3 and R4 are interchanged. So by interchanging R3 and R4, it is going to be 4 0 minus 4 0 remains same only, 0 2 0 1 remains same only. So 0 1 0 2, and this is going to be 0 0 0 0. Right? Is it correct or not? Look at once here, 4 0 minus 4 0, 0 2 0 1. So this is R3 plus R1 0 0 S0, right? And 1 0 2. Next one is, look at. So is it in the echelon form? Not in the echelon form. Look at here, this is the first non-zero element, we have 1 0 before that, and this is the first non-zero element, again we have 1 0, but more than 1 0 should be there. So I am going to make this element as 0, therefore R3 changes, 2 times R3 minus R2 only, 2 times R3 minus R2. So it is going to be, look at, it is going to be, right, it is going to be 4 0 minus 4 0, am I right? And this one is 0 2 0 1 same only, 0 2 or 2 minus 2 0 0 4 minus 1 3, and this is 0 0 0 0 only. Yes, this is the echelon form. So this is a non-zero row, this is a non-zero row, this is a non-zero row. Observe once here, this is the first non-zero element, this is the first non-zero element, before this one 1 0, more than that zeros, right? So finally what is the rank of this matrix? Rank of A equal to 3 only. This is the procedure. Okay. So by performing the elementary operation, right, performing the only row operations, we reduce the given matrix into row echelon form. So which option? So 3 is the correct one. Okay. Yeah. Let us see the next one. So the rank of the matrix P equal to 1 1 minus 1 2 minus 3 4 3 minus 2 3, Q equal to minus 1 minus 2 minus 1, right? Then be the two matrices here 1 minute, right? So here the question is consider the matrix P equal, P is this one, right? And Q, P and Q two are the two matrices. Then what is the rank of P plus Q? What is the rank of P plus Q? So the two matrices and the rank of P plus Q is what? Look at, take the summation of the two matrices. Very simple, right? So P plus Q equal to, what is P plus Q? 1 minus 1 0, minus 1, minus 2 here, and 6 plus 2 8 here, 12 minus 3 9 here, 6 plus 4 10 here, and 5 plus 3 8 here, 10 minus 2 8 here, next 5 plus 3 8 only. Is correct or not? 0 minus 1, right, minus 2, and 6 to 8 9, and 6 4 10 8 and 8 and 8, right? Look at, this is going to be, look at. So this is not in the echelon form, right? So I am going to apply, look at. We can interchange first R1 and R2 are interchanged. So by interchanging on R1, R2, we get 8, 9, 10, 0, minus 1, minus 2, and next one is 8, 8, 8 only. Am I right, correct or not? Next, I am going to apply this operation. Look at what is the operation. I am going to apply R3 changes, R3 minus R1 only. So by performing this operation, it is going to be, look at. So 8, 9, 10 remains same only, 0, minus 1, minus 2 remains same only. So 8 minus 8, 0, 8 minus 9, minus 1, 8 minus 10, minus 2. Right. Next one is still not in the echelon form, right? So next step is what? I am going to perform this operation. What operation? R3 changes, R3 minus R2 only. So by performing this operation, look at, this is going to be 8, 9, 10, 0, minus 1, minus 2, 0, 0, 0 only, right? Therefore, what is the rank of the matrix? 1, 2 non-zero rows are there, so rank of A equal to 2 only. Or we can use the determinant concept also, right? If determinant is non-zero, rank of the matrix is 3 here, determinant is 0, rank of the matrix not 3, maybe 2 or 1. Okay, any method you can apply, right? So this is the best method, row echelon form is the best method to find the rank of the matrices. So rank of A equal to 2 only. Yeah. Next one is, let us see the next question. If every element of 5 by 7 is 1, then the rank of the matrix A is what? Every element of 5 by 7 matrix is 1, then rank of the matrix is what? See one's option, option A 7, option A 7 is not correct answer, because the reason is what? Rank of a 5 by 7 matrix is less than or equal to minimum of m comma n. That is what? Minimum of m comma n is what? 5 comma 7 means 5 only. So rank is either 5 or less than 5 only, and rank of a non-zero matrix never equals to 0. So either 5 or 1. So what is 5 by 7 matrix? Like 1, 1, 1, 1, 1, 1, right? 5 rows and 7 columns, 3, 3, 6, 1. So like this 1, 1, 1, 1, right? So like 5 rows and 7 columns. So that is, if we apply by performing the operations like R2 minus R1, R3 minus R1, R4 minus R1, R5 minus R1. So except the first row, every row is going to be 0, right? So rank of the matrix is going to be 1 only. Means what? We get like 0, 0, 0. Here also 0, 0, except the first row. Every row is 0 row only. So rank of A equal to 1 only. So option D is the correct answer. Am I right? Understood or not? Rank of A is going to be 1 only. Yes, Nirisha, rank of A is 1 only, right? Option D is the correct answer. Next, coming to, right, these are the problems related to rank of the matrix. Next one is a non-homogeneous system of linear equations. Okay? So how do we solve these non-homogeneous system of linear equations? And even homogeneous system of equation also. How do we solve the homogeneous system of equations? Let us see the terminology first. Frequently used terms are the terminology or definitions in the system of linear equations. So here solution means what? The value of the vector, the value of the vector x satisfying the system Ax equal to b is called a solution, right? Means for what value of x this equality holds, such x is called solution of the system. So augmented matrix A slash B, the matrix containing A and B, means for example the system is like, for example, x plus 2y plus 3 equal to 4, 3z equal to 4, right? X minus y plus 2z equal to minus 1. For example, 2x plus y minus z equal to 0. This is a system of equations in 3 unknowns and 3 equations, right? So what is the coefficient matrix? 1, 1, 2, and 2 minus 1, 1, and 3, 2 minus 1 is A, coefficient matrix A into. X means what? X, Y, Z unknown vector. Right hand side vector is what? 4 minus 1, 0 is the right hand side vector. Am I right? Correct or no? 4 minus 1, 0. So what is augmented matrix A slash B? A slash B means what? A and B together. That is what? 1, 1, 2, 2 minus 1, 1, 3, 2, 1, minus 1, and 4 minus 1, 0. This is called augmented matrix. Okay? So generally number of equations are denoted by m and number of unknowns are denoted by n. Number of unknowns or number of variables. So here look at augment matrix means what? A slash B means the matrix containing A and B like this one, A slash B. Next, consistent. What is the consistent? A linear system of equations is said to be consistent if at least one solution exists, right? And inconsistent means what? The system has no solution, right? These are the frequently used terms or definitions in the system of linear equations. So look at these, the geometrical interpretation of system of linear equation in two-dimensional. This is in what? Two-dimensional space, 2D, right? So two-dimensional means what? For example, a11x plus a12 into y equal to b1. Similarly, a21 into x plus a22 into y equal to b2. So we know that each equation represents a line segment in 2D. Okay, so what are the possibilities for what are the possibilities for the system of linear equations? Look at here, each one represents line segment. So the line segments, this blue color and another color, right? These two may intersect at one point, unique point, that is consistent. The point is the solution intersect point. Here look at here, both are coincide. Both are coincide. So here these are the parallel lines. So no solution. So here only one solution. Here infinitely many solutions. Here no solution. So can we say that the possibilities for this system of linear equation is what? Either a unique solution or no solution or infinitely many solutions are the possibilities. This is in what? Two-dimensional space, right? What about three-dimensional? Look at. So in three-dimensional, each equation represents a plane, right? So a linear system of equation, three variables interpreted as planes in three-dimensional space. Look at. So look at here, this is the common point of intersection here. Here common line of intersection in these two cases. So this is consistent, this is consistent, this is also consistent. Look at here, coming to this one here, parallel planes, no common points or no common lines. Here no single line of intersection here, even here also no single line of intersection. Yes, understood or not? So here look at here, only one common point is there. So we can say that unique solution. Here every point on this line is a solution. So infinitely many solutions. Here also every point on this line is a solution. So infinitely many solutions. But whereas in these three diagrams, there is no common point or no intersect line. So inconsistent. So finally, what is the conclusion? For a given system of linear equation, what are the possibilities? Either unique solution or no solution or infinitely many solution only possible. So what are the methods? How do we solve the system of linear equations? This is the geometrical interpretation of system of linear equation, three-dimensional. Look at. So there is a method, basic method, which is called matrix inverse method. By use, right? Look at here, a n by n, right? So this is method is for what? For a n by n only. N by n and x equal to b, right? Means what? Number of equations equal number of one, then only this method is valid. Because for a square matrix only we find the determinant. Look at here. So what are the possibilities? If det A is non-zero, then unique solution exists. What is the solution? Did you know the solution? Det A non-zero means what? A inverse exists or not? Therefore, the solution is x equal to A inverse into B is the solution. What about det A equal 0? Det A equal doesn't mean no solution. Det A equal 0, and there is, look at, there are two possibilities. The adjoint A into B equal to O, not 0, this is O, null matrix, then infinitely many solutions. If adjoint A into B is not equal to O, no solution. So it's very clear, whenever the system is, if the given system of equations is n by n system, number of equations equal number of unknowns, and det A is non-zero, no doubt unique solution. What about det A equal 0? Either infinitely many solutions or no solution. Depends on what? These two conditions. What conditions? If adjoint A into B equal to O, infinitely many solutions. If adjoint A into B not equal to O, then no solution. Right. So what is the disadvantage of this method? Finding this adjoint A and production multiplication of two matrices and determinant of higher matrices is too long, complicated. So this method is preferable for up to means 3 by 3 matrices only. Size of 3 by 3. 3 equation, 3 unknowns. Right. Next one is we have another good technique also. This is also very good technique, which is called Kramer's rule method. This is also for n by n system only. That is number of equations equal to number of unknowns. So what is the method here? Delta equal 0. What is the delta? Here delta equal to determinant of A. What is the delta I? Delta equal determinant of A. What is A here? Look at here. So here A, delta I means what? determinant of the matrix AI obtained by ith column of A is replaced by right hand side of B, right hand side B. So look at here, delta is not equal to 0, then unique solution, and the solution is xi equal to delta I by delta, x1 equal to delta 1 by delta, x2 equal to delta 2 by delta, x3 equal to delta 3 by delta. And next one is what? Delta equal to 0 and all delta are 0, then infinitely many solutions. And next one is delta equal to 0 and one or more delta is are non-zero, right? Then no solution. Again, what is the disadvantage in this method? This method is also for n by n system only, and finding determinant of higher order matrices is not possible, 4 by 4, 5 by 5, 6 by 6. So this method is not preferable. So what is the best method to find the solution of given system of equation means Gaussian elimination method. So for any system A m by n x equal to b, any system, what is m here? M equal to number of equations always. Please remember that the rows represents number of equations. N means what here? N means what? Number of unknowns or variables. For example, A is a 2 by 3 into x equal to O means, for example, A is a 3 by 4 into x equal to O, x equal to B means, what does it mean? 3 rows, 4 columns. 3 rows means what? 3 equations, 4 unknowns. So M means number of equations. That is rows of a matrix, each row of a matrix represents an equation, and columns, number of columns equal to number of unknowns, right? So look at here, what is the method? Here we find based on the rank, any system, not only m by n, any system of equations, right? So this method is applicable. Here what do we do? If rank of augment matrix is not equal to rank of A, inconsistent, no solution. If rank of augment matrix equal to rank of A, consistent. But what is consistent? Consistent means again two cases are there. What I told in the beginning, consistent means at least one solution, means either unique solution or infinitely many solution, because only 3 possibilities are there for system of linear equations. So look at, so rank of augment matrix equal to rank of A equal to consistent means what? Again 2 cases. What are the 2 cases? If rank of augment matrix equal to rank of A equal to R equal to N, what is R? R means rank. N means what? What I told, N means what? Number of unknowns. Then unique solution exists. If rank of augment matrix equal to rank of A equal to R but less than N means infinitely many solutions exist. Okay? So this is the method based on the what? Rank of. Please remember here the main thing is remember to be is what is the important point here? M means number of equations, N means number of unknowns. Right. So look at it, doesn't depends on the determinants, just depends on the rank only. By using the rank we can solve any system of equations. This is about non-homogeneous. And what about homogeneous? Homogeneous system means what? Ax equal to y is called homogeneous system. Means what? All the right hand side values are zeros. Such system is called homogeneous system. Right. So here we use the following terminology: trivial solution, or we call it a zero solution also. Trivial solution or zero solution. What is the trivial solution? X equal to O. That is x equal to like 0, 0, 0 in 3 dimensional. This is called null vector. This is called trivial solution. Non-trivial solution means what? Otherwise non-zero solution. That is either non-trivial solution, or we can say that this is non-zero solution. Non-zero solution. So what is the procedure, right? How do we solve this? What are the possibilities for a given homogeneous system of equation Ax equal to O, right? Look at the procedure is. So this is the A m by n x equal to O. So here m means what I told you already. Already we know that m means number of equations, n means number of unknowns. Am I right? Correct or not? So here m equal to n. M equal to n means what? Number of equations equal to number of unknowns. M not equal to n. So whenever m equal to n means what? A is a square matrix. Determinant is non-zero, then only trivial solution. If determinant is 0, then infinitely many solutions. If m not equal to n, m not equal to n means what? Number of equations are not equal to number of unknowns. Then we could not find the determinant. Only rank can be evaluated. So look at m less than n, number of equations less than number of unknowns, then always infinitely many solutions only. In which case? Homogeneous case. If m greater than n, m greater than n means what? Number of equations is greater than number of unknowns, then there are 2 possibilities again. If rank of A equal R equal, then only trivial solution. If rank of A equal R less than n, then infinitely many solutions. So finally we can conclude that if rank of A equal to R equal to n, only trivial solution. If R is less than n, infinitely many solutions exist. Out of infinitely many solutions, few solutions are linearly independent. How many solutions are linearly independent? Look at. So the next one is null space. What is the null space? For example, look at x plus y equal to 0 and 2x plus 2y equal to 0. For this system, we know that 0, 0 is a solution. Yes, correct or not? 1 minus 1 is a solution. Minus 1, 1 is a solution. 2 minus 2 is a solution, etc. Infinitely many solutions we have. Yes, correct or not? Once observe these solutions, 1 minus 1, minus 1, 1, 2 minus 2, these are multiples of k times, right, 1 minus 1 or not? By giving k equal to 0, first one, k equal to 1, second one, k equal to minus 1, k equal to etc. So all the solutions are like what? Multiple of this one. So this is called linearly independent solution. Remaining are what? Dependent solutions. So how many such linearly independent solutions will exist? So that is what? Set of all solutions of the homogeneous system Ax equal to O is called null space. Right. Nullity means what? Dimension of the null space. The number of linearly independent solutions is going to be n minus r. What is n here? This is very important. N is what? N is the number of variables. What is r? Rank of the matrix A. So the frequently occurred questions on this homogeneous system were related to this nullity and dimension of null space. Dimension of null space nothing but nullity only. This is very important concept. Right. So rank plus nullity equal to n only. Yes, very clear. Rank means r, nullity means n minus r. So r plus n minus r is n only. Right. So this is about homogeneous system. Right. So we look into questions related to this non-homogeneous and homogeneous system. Look at, consider the system of linear equations 3x minus y plus 4z, right? The system will have infinitely many solutions if which are the following. See here you can use the determinant, but determinant means what? When determinant is not equal to 0, we can say that unique solution. But determinant equal to 0 doesn't mean infinitely many or no solution. Depends on another verification, adjoint A into B equal to O or not. So that's too long. So what we do means we apply the Gaussian elimination method is the best method. Look at. So what is the method? We write like this: 3, 1, 6, minus 1, 2, 5, and 4, minus 3, alpha, and 3, minus 2, minus 3 only. So this is the give augmented matrix. Am I right? Correct or not? So reduce this matrix into echelon form. That is what? R2 changes. 3 times R2 minus R1. Next R3 changes. R3 minus 2 times R1. Yes, correct or not? 3 minus 1, 4, 3. 1, 2 minus 3 minus 2, 6, 5, alpha minus 3. So by reducing, by performing these operations, the matrix leads to the following form. What form? Look at. 3 minus 1, 4, 3 remains same only. 1 minute. 3 minus 1, 4, 3 remains same only. 3 minus 3, 0. Am I right? 3 2s are 6, 6 minus or minus 1 means 7. Next one is minus 9, minus 4, minus 13. Next one is minus 6, minus 3, minus 9. Next one is 0. 2 5s are 6, 6 minus R3 minus 2 R1. 5 minus or minus 2, 7. Next one is what? Alpha minus 8. Alpha minus 8. Next one is what? Minus 3, minus 6, minus 9. Right. Next, I am going to apply, look at this operation. What operation? That is R3 changes. R3 changes R3 minus R2. So by performing this operation, the matrix leads to the following form. It is going to be 3 minus 1, look at. 3 minus 1, 4, 3, 0, 7, minus 13, minus 9, and 0, 7 minus 7, 0, alpha minus 8 plus 13, so alpha plus 5, and this is 0 only. So what is the question? You are required to find the alpha value such that the system will have infinitely many solutions. Look at, very simple. If it is 0, then rank of A equal to rank of augment matrix equal to 2 or not, because this is completely 0 row. So 2 less than number of unknowns, 3 only. So we'll have infinitely many solutions. infinitely many solutions. Infinitely many solutions. Therefore, for what value of alpha, this alpha plus 5 becomes 0? Very clear. Therefore, alpha equal to minus 5 only. Therefore, for alpha equal to minus 5, we get infinitely many solutions for this system. Very good example on the system of linear equations. Understood or not? Therefore, alpha equal to what? Minus 5. Option A is the correct answer. Right. Yes, Nirisha, alpha is minus 5. Am I right? Correct or not? Previous problem, check once. Alpha equal to, yeah, minus 5. Not alpha equal to 5, alpha equal to minus 5, right? Look at next one is, let's see the next problem. X minus y plus 2z equal to 4, 3x plus y plus 4z equal to 6, x plus y plus z equal to 1 has option A no solution, option B only one solution, option C two solutions, option D multiple solutions. Once observe the options x equal to 1, y equal to minus 1, z equal to 1. Verify is a solution or not. Put here 1 minus 1, that is 2 minus, this is what 2 plus 2, 4, satisfying first equation. And next second equation 3 minus 1, 2 plus 1 is satisfied, and third equation is satisfied, right? So 1 minus 1, 1 is a solution. Next verify 4 minus 2, 1 is a solution or not. 4 minus 2, 1 is a minus 1 is a solution or not. 4 plus 2, 6, 6 minus 2, 4 satisfied. Next second equation 4 minus 2, 2 minus 4 minus 3 4s are 12, 12 minus 2, 10, 10 minus 4, 6 satisfied. Next x 4 minus 2, 2, 2 minus 1, 1 satisfied. Means what? 1 minus 1, 1 is satisfying this point, and this 4 minus 2 minus 1 is also satisfying. Means what? 2 are possible solutions. But according to our theory, more than one solution means what I told you, infinitely many solution only possible. Correct or not? Only 3 possibilities are there. What are 3 possibilities? Either no solution, or unique solution, or infinitely many solutions for the non-homogeneous system. But here 1 minus 1, 1 is a solution, and 4 minus 2, 1 minus 1 is also solution. Means what? 2 solutions are possible, means what? Third one is also will exist. So infinitely many solutions will be there. So which option? Without any calculation, multiple solutions is the correct answer. I hope this problem is clear, right? Very good example. No need to compute, no need to reduce the matrix into echelon form, etc. By verifying options, very clear. Multiple solutions is the correct answer. Right. Let us see the next one. The question is, consider the system of equations, homogeneous system is given. Which of the following statement is correct? Right? No solution exists. I told you clearly, homogeneous system is what? Always constant. Always 0, 0 is solution by default. Okay? So no solution is not a correct answer. So this is not a correct answer. Next, finite number of non-zero solutions. Finite number of non-zero solutions is not a correct answer, because non-zero solution may exist or may not exist, but if exists infinitely many. So two independent solution, unique solution. Which of the following is the right? So means what? Which of the following is correct means what? Either C or D. Right? Look at B, A and B are not correct. So very simple. Look at 1, 2, 3, 3, 4, 4, 7, 10, 12. Okay. So we can find determinant of this matrix, or we can reduce into echelon form also. Anyone we can. So for example, R2 changes. R2 changes, R2 minus 3R1, and R3 changes, R3 minus 7 times R1. Even we can find determinant also, right? 1, 2, 3, 3 minus 3, 0, 4 minus 6 minus 2, 4 minus 9 minus 5. Next 7 minus 10, 0. 10 minus 14 minus 4, and 12 minus 21 is what? Minus 9. 12 minus 21. Correct or not? 1, 2, 3. 1, 2, 3, 3, 4, 4, 7, 10, 12. R2 minus 3, 3 minus 3, 0. 4 minus 6 minus 2. 4 minus 9 minus 5. 7 minus 7, 0. 10 minus 14 minus 4. 12 minus 21 minus 9. Look at next step is what? Next step is what? R3 changes. R3 changes. R3 minus 2 times R2. So 1, 2, 3, 0 minus 2 minus 5, 0, 0, minus 9 minus plus 10. Minus 9 plus 10 means 1. So very clear, rank of A equal to 3. So equal number of unknowns means what? Only unique solution, that is 0 solution only will be there. Right? Only what solution? Unique solution exists. Unique solution means what here? Unique solution means what? Only trivial solution exists. That is only trivial solution. We can say that only trivial solution exists. Trivial solution means what? That is 0, 0 is the solution. So rank is not rank is equivalent to 3 number of unknowns means what here? Determinant of the matrix is non-zero. No doubt. We can verify, right? So is it okay? So only trivial solution exists. Yes. So I am moving to next problem. Look at here. Consider the system 1, 1, 2, 4, 6, minus 4, minus 8, minus 12. The x, y, z equal 0, 0. The dimension of null space is what? Dimension of null space means what? Nullity. Nullity means what? Formula n minus r. N is what here? N is what here clearly? N equal to 3 or not? Number of unknowns 3. So rank is required. R is required. So R means what? Find the rank of this matrix. R2 changes. Right? R2 changes. R2 minus 2R1. And R3 changes. R3 plus 4 times R1. So by performing these two operations, the matrix leads to the following form. What form? That is 1, 1, 1, 1, 2, 4, 2 minus 2, 0, 4 minus 2, 2 only, and 6 minus 2, 4 only. Next, this is 0, minus 8 plus 4 is minus 4, minus 12 plus 4 is minus 8 only. Right. Still not in the echelon form. Another one more operation, that is R3 changes R3 plus 2 times R2 only. So it is going to be 1, 1, 1, 1, 0, 2, 4, 0, 0, 0 only. So very clear, rank of this matrix is 2 or not? Means what? Infinitely many solutions will be there. Out of infinitely many, how many are linear independent means what? Nullity. So dimension of the null space equal to dimension of null space equal to that is nullity equal to n minus r. N minus r means what? 3 minus 2 equal to 1. Means what? One independent solution exists. That is one independent solution exists. Right? Infinitely many will be there. Out of infinitely many, one independent solution exists. That is one parameter family of solutions. Okay? So this is the problem related to dimension of null space. Very good example on this nullity. Look at another example. So let's see next one. Consider a 4 by 5 x equal to O. The solution of the system are of the form x equal to k into 1, 2, 0, minus 1, 3, where k is a parameter, then rank of A is what? See, once here A 4 by 5, right? The question is what? A 4 by 5 x equal to O. Right? Means what? M equal to what I told you? M means number of equations. Each row represents an equation. M equal to 4. And 5 means what? N equal to 5. Number of unknowns 5. Look at the solutions are like what form? X equal to k into this form or not? Means what? This is the linearly independent solution. So the solutions are like what? X equal to k times this 1, 2, 0, minus 1, 3. Multiples of this solution. So one independent solution is there. So therefore, one Li solution is given. Means what? Number of independent solutions is what? N minus r equal to given as 1. Yes, correct or not? N minus r is given as 1. N is what? 5. R is required. So clearly R equal to 4 only. So the rank of the matrix is going to be 4 only. Very good example on this nullity. Right? We have an identity, rank plus nullity equal to N only. Let us see this one. consider the following statements, right, which of the following is correct. So there are some statements. Det of A equal det of A transpose. Det of A equal det of A transpose. Is it correct or not? Yes, correct only. The system Ax equal to O is always consistent. Yes, Ax equal to, for every system, for example, x plus y plus z equal to 0, x minus y plus z equal to 0, for every homogeneous system, any homogeneous system, 0, 0 will be there, no doubt. 0, 0 is always a solution. For this example, 3-dimensional, 3 unknowns. In general, n-dimensional, right? But non-trivial solutions may exist, may not exist, but if exist, infinitely many will be there. Out of infinitely many, n minus r solutions are linearly independent solutions. This is the concept, right? So Ax equal to O is always consistent. Yes, this is also correct. Next, the system Ax equal to B, here B not equal to O means what? Non-homogeneous system is always consistent. Is it right? No, no guarantee. Non-homogeneous system may consistent, may not consistent. Depends on what? Whether rank of A is equal to rank of augment matrix or not. So this is not correct. Next, the fourth statement, if det of n by n equal to 0, then the system A n by n x equal to B has always no solution. Is it true? A n by n into x equal to B, right, is equal to A equal to 0, what happens? Maybe no solution or infinitely many solution. Depends on what? Adjoint into A into B equal to O or not O. Am I right, correct or not? So this is also wrong statement. So which of the above statements, right? Statement 1 and 2 are correct. So 1 and 2 are only correct. Option B is the correct one. So this is about system of linear equations, rank of the matrix and basic concepts. In the next session, we'll discuss about the eigenvalues, eigenvectors and Cayley-Hamilton theorem and other concepts. Thank you.